Now before we can start applying all that lovely motion capture data we got from our Xsens MVN system to our characters, we're going to need to put them in a T-Pose and characterize them. Now I've already made a video showing you how to do this manually, which is fine if you've only got one character to work with and you can take as long as you want. But if you're working on a project where you've got multiple characters and tight deadlines, and let's be honest, on those kind of projects, you're probably going to do this more than once, then you're going to need ideally a way to do this automatically, and that's where Python scripting can come in. So in this video, I'm going to show you how to T-pose your character using IK constraints, and then how to create a character, complete the character mapping, and characterize it in one click. And also, even if you're not into Python scripting, you can still pick up a way of T-posing your character using IK constraints. So let's get started. Okay, so the first thing we need to do is import our PyFBSDK module. And then to get started T-posing our character, we're going to do the same things as we would if we were doing this manually. So the first thing we need to do is center the hips. So to do that, we need to find our hip object. Rather than using the FB find modules, to do that I'm just typing the start of the word, the FB find, and then hitting Control space. Rather than using one of these and using a hard-coded value, what we're going to do is bring in the XML template dictionary that we've saved and use that. This means once you've characterized your character manually, you can use that XML template file that you've saved to characterize the rest of your character, as long as your joint names don't change. To get the details from the HIK template file, what we're going to do is convert that into a dictionary file. So to do that, we're going to import xml.etree.ElementTree as etree. So this allows us to use a Python to read in a XML file. So now we can use the etree to parse the XML file. So into here we're going to need to pass our XML file. So to do that, I'm going to import OS and use this to build a string to our file path. This just means if I use a different OS, if we use it on Linux or Windows, it doesn't matter. This is going to take care of all the different forward slashes and backslashes and things. And also, because this is stored in your user data, it means the person using it can pick it up and it'll pick up their user data where the file's stored, rather than having to change the path name depending on what the username is and things. So we can create our XML file path. So we're going to use os.path.join. So this is going to build our file string. So to get the user path, we can use os.path.expanduser and then put the tilde in. That will give us the user path. And then we can use the folder where the HIK characterization template lives. So that's appdata, roaming, autodesk, HIK characterization tool 6, template, and then we're going to use the HIK template file. But obviously, if you wanted to change this, you could add in your own XML file so that you can read in one that you've created yourself. So if we print this now, just comment this out, we can see this gives us the path to our HIK template tool. So now we can pass that into etree for it to parse it. So now we can create a dictionary to store those values. So now we can read our parsed XML file. So then from each of those lines we can grab the joint name. So if we run that now, we should see our joint names. So we can see we've got our list of joint names. Then what we can do is we can say if it finds a joint name, so that we don't get any empty slots, we can say the slot name is line.attribute.getKey. So now we can just print those to check that we're getting the right thing. Now we can run that and just check that we're actually getting the slot name and then the joint name. So these are using the standard joint naming convention for MotionBuilder, but if you had your own joint naming, obviously they'd show up as a different joint name in here, but that just means now we can use the values in the character template to find the name of the joints that we want to find in the scene. So this way we don't have to use hard-coded values, we can change it depending on the character or depending on the project that we're working on. So now we know we're getting all the right values, we can add them into our dictionary. And then to check our dictionary, we can just import pprint, so we can print our dictionary in a slightly more human-readable form. And then we can print our dictionary out and just check that all the values are correct. So you can see we've got our slot name and our joint name, although they're almost exactly the same because they're using the default MotionBuilder naming convention. If you were using your own joint names, they'd show up in this second column. So using this method just gives us a different way of being able to get the joint names without using hard-coded values and FB find and then having to change it depending on the character you're doing or the project that you're working on. So with this we can always import the XML file and then use that to find the joint names that we want in our character. So to make this a little bit more usable, we'll turn it into a function and then we can just check that that's working. and then print the result. So now we've got our character HIK template as a dictionary. We can use normal dictionary functions to find out the name of the joint that we want to find using the slot name in the character. So to get the name of the hip joint in our character, we can use a dictionary and then use get hips. That returns the name hips. So now we can use the find model by label name and put in our character hips name. So now we can just use the selected, we can just select that object if it's found. You can see that grabs our character's hips. So now we can say if it doesn't find the character's hips object, we'll just print an error for now. But if it does, what we're going to do is you're going to grab the current position of the hips, and then we're going to reset the X and Z values, but we're going to leave the Y values as they are. So to do that, we're going to create an empty vector that we can fill with the character's current hip positions. And then on the character hips, we can use get vector. And the first value we need to do is give it the empty vector to pass the vector that it just gets into. And then we can use FB model transformation type model translation, and we use true to get it in world space. So if we look at those values now, that gives us the current position of our character's hips. So if we check these values up here against these in the scene, we can see they're the same. So now we can create our character 0 hips vector. So we'll set the first value X to 0, and we can use the hips vector that we got its current position for Y. Use the first letter, so that's a list, so we can get the second value of that. And then we can set the Z value to 0 again. So this will reposition the character's hips at 0 on X, 0 on Z, and then keep the current position in Y. And then we can use set vector to set the position of our character's hips using the 0 hip vector, and then we'll do the transformation type as translation in world space. And then if we run that, you can see our character then zeroes in the scene. So if we had it somewhere else, if we T-pose it in a different position, we could run that script and it's always going to put him back at the center. This does assume that the character's standing upright. If it's not, you may have to adjust the height, but you can always go in here and edit this afterwards manually. But this is always going to return your character to the center of the scene. So now we have our character centered in the scene. The next thing we're going to need to do is to zero the rotation on the joints locally. Now handily, we can get to all the skeleton joints in the scene using the fbsystem.scene.model skeletons. So in here we can say for skeleton and fbsystem.scene.model skeleton, skeleton.selected equals true. So this is just going to select all the skeletons in our scene. So if we look in the schematic view and then run that, you can see it selects all our skeleton models. It doesn't grab any of the nulls or any of the geometry, it just grabs the skeleton. And this time we can use skeleton.rotation, so this only works on local rotations, and we can set that to fb vector 0. And if we run that, we can see that puts all our character joints at 0. So if we look at one of these now, we can see if we switch into F5 local and rotation, we can see these are all set to 0. So in this example, setting the rotation to 0 does put the character in a T-pose, but typically this may not be the case for your model. You may find that it's either in a pose where the arms are down like this, or you may find it's in an I pose where the arms are down by the side. So the next thing we're going to do is look at T-posing the character. Now rather than using the rotation method I did before when I showed the manual way of doing this, we're going to use an IK method. So this is a bit of a hat tip to Rigging Dojo and Brad and the guys over there. So they had a demo, I'll link to the video below, where they showed how you could T-pose a character using IK chains. So what we're going to do here is we're going to build the IK chains and then use that to make sure all the limbs are aligned. So the first thing we want to do is get the end joint in our IK chain. So typically you'd set up an IK chain and we put it on something like the left hand or the left wrist. Now luckily we already have a way of getting the joint using the dictionary method that we used before for the hips. So we're going to grab this and turn this into a function because we're going to need to do this for both hands and the feet. So now we've created a function, we can use that to get our left hand joint. So if we just look at an IK constraint, we can see we need our first joint, end joint, and an effector, and also a pole vector object. So we have our end joint, so what we can do now is grab each of these joints in this chain using the parent command. So we can say the left forearm joint is the parent to the left hand, and then we can say the left arm is the parent of the left forearm joint. So now if we just want to check that we've got all the correct joints, we can just run that script to make sure that we're selecting all those joints. Look in the schematic view. We can see we've got our left hand, our left forearm, and our left arm. So that gives us all the joints in this chain. So now we have our first joint and our end joint. So the next thing we need to do is create an effector. So to create our effector, we're going to use the FB model null, and then we just give the null a name, and then we can set it to show. So that just means it'll show up in the viewport. And then the last thing, we'll just give it a size, and then we can run that. And if we look in our scene view, We've got our left IK effector at the center of the scene. So now what we want to do is the equivalent of grabbing this and then aligning it to the translation of our hand. So to do that in code, we can get the vector of the hand and then use that to set the vector of our effector. So same as before, we can do character left hand, get vector, and then pass it into the empty vector that we've created. And then we're going to grab its transformation type translation in world space. Now we can align our effector to that vector. And then we can run that. So now we've created an IK effector and align it with the wrist. So we've got our effector, so the next thing we need to create is a pole vector. So to do that, we can use this same code again, but this time we're going to use the FB get matrix and set matrix to get the rotation and the position of the object in space. So now if we run that, we can see we now have a IK effector aligned with the hand, and we have a pole vector aligned with the elbow. So now we've got all the bits to add into our IK chain. What we need to do is actually create a chain IK constraint. So to do that, we're going to get the FB constraint manager. Unfortunately, to create a constraint in MotionBuilder using Python, you can't just use the FB constraint manager and then do something like create type and then pass it chain IK and it's going to create that type of constraint. What we need to do is get the constraint type index from the constraint manager and then use that to create the type of constraint that we want. So we can use for constraint type index in range constraint manager dot type get count. So to see what types of constraints you can get, you can then use constraint manager type get name constraint type index, and that's going to give us all the types of constraints that are in there. So we want the chain IK. So now we can use the chain IK name to get the constraint type index to create the type of constraint that we want. So now we can use chain IK equals constraint manager type create constraint and use the constraint type index that we've just found. So now if we run that, that's going to create our chain IK. And then as with most things in MotionBuilder Python, we can change the name. So now we have a constraint, we need to get hold of each of these and then pass the objects that we found earlier into those slots. So to do that, we're going to use the reference group get count. So the same way as we did to find the chain IK constraint in the constraint manager, we can use the reference group index to find the slot name in the constraint. So if we print that out, we can see we get a first joint, end joint, effector, floor, and pole vector object. So that's each one of these slots. So now we can say if the reference group name is first joint, we can use reference add, the reference group index, and then the character left hand to add our joint to the hand. Now you can see we've created our left hand IK. We've got the first joint and we've put in the left hand. So now we can add the rest of the objects into the other slots. So now we can run that. So now we've created our IK effector. We've added the first joint, the end joint, the effector, and the pole vector in. The last thing we need to do is use snap to turn this on. So now we've created our IK effector. We've added all the joints and objects in, and now we've turned it on. So now if we grab our IK effector and move it around, we can see that's working on the position of the hand. And then if we move our pole vector, we can see that's working on the position of the elbow. So the next thing we need to do is figure out where to position these two nulls to make sure that this arm's straight and that the wrists aligned with the shoulders. So what we want to do is take this left IK effector and then do the same as the alt left click drag align translation Y, so that it's the same height, and then also translation in Z. So that's going to set it on the forwards and backwards here. And the next thing we need to do is make sure that this arm's completely straight. So if it was built bent, we need to make sure that this value, this X value, is at the full stretch. So what we can do is we can grab the Y values of these, because there's a translation in Y, which is the length of the joint. So this Y position here is the length of the forearm from the arm. And then if we grab the position of the left hand, that's the distance of this joint here from the arm to the hand. So we can use these to calculate the position of this locator to make sure that this arm's at full stretch. So if we just tidy our scene up. So to calculate the limb length, we can get our character forearm joint and get the translation in Y, which is the first value in number 1 value in the list. Then we can get our character left hand translation in Y and add those together, and that gives us our limb length. So now we know the length of our limb, we can offset the IK effector and the pull vector based on the position of our left arm joint. So the first thing we're going to need to do is get the position of our left arm joint in world space. So the first thing we're going to do is calculate the X position using the joint length. And then if we just print that value, so if we compare that value to the position of our arm at the moment, we can see it's pretty much, if you take into account the bend in the arm, that's going to be pretty much in the right position. So now we can use that to set the position of our IK effector. And we're also going to use the position of our arm joint to set the position of the pull vector. So now if we just print these two values, so if we compare the position for the IK effector, we can see that's almost where this arm is now. Obviously this arm was built in a T-pose, but if your arm was built in a more of an A pose or an I pose, then this would give you the position offset for the arm to be out here. So if you look at our value of our pull vector constraint, you can see I've aligned that to the left arm and then moved it back in Z so that it's behind the character. So now we can use a left arm joint vector to align the pull vector and the IK effector to make this arm nice and straight. So now if we run this, we can see we've created a IK effector. We've added in all the joints, the effector and the pull vector, and then we've set the position so this arm's nice and straight. And we've also set up the pull vector to make sure that this elbow's on the same plane and nice and flat. So when we move this IK effector in, you can see it bends level with the shoulder. Okay, so now we have our code working for one limb. We can go through and serialize it because we're going to have to do this 4 times for each of the limbs. So now I made a function to T-pose the arm. There's one thing we need to check, because if we try this with the right hand, you'll see it breaks the arm, it moves the arm across, and that's because this is actually negative values. So what we need to do is change some of the maths in here. So what we need to do is, where we're creating our offset here, we need to check whether it's on the left or the right side. So the way we can check that is to check the first joint vector 3D in X is less than 0. So that means if it's a negative value, then it's going down the negative axis, so it'll be the right hand side. If not, then we can just use the limb length. So now if we run this again on the right arm, you can see we don't get that arm crossing back over here. So this will T-pose an arm correctly, but if we try this with the leg, so if I change this to right foot and then run it, you can see that breaks the foot because it's offsetting down the wrong axis. So this offset is offsetting in X, which is down here. We want to be offsetting in Y to straighten the leg down in negative Y. So we're going to have to change this code slightly to make it reflect that. So to do that, we're going to add a is arm check in there. You could do this different ways, but I'm just going to use this. So if it's an arm joint, then we can offset the X as we were doing. But if it's not an arm joint, so if it's a leg joint, then we can offset it in Y. So now if we run that with arm joint set to false, that now gives us a IK chain on the leg. So now we can set this up and run this on the rest of the joints. So now we've got an IK set up for each limb. We can go in and just make sure these limbs are straight and aligned. So like here, if we want to put a slight bend in this wrist, we could just move this in slightly. It's got that 72.3, and then we can do exactly the same on the other side. And then with the legs, we can grab both IK effectors, go into a right view, and then just pull these back and align them in the correct position. So now we've got our character T-pose, we can go in and characterize it. So to start with, we want a character name. So to create our new character, we can use FB character. So now if we run that, that gives us a character called Nigel. Now to fill in those slots, we can use a get character template as dictionary. Then we can use for slot name, joint name in character slot name dictionary items. That's going to give us the slot name that we need to look for, and then the joint names to put into the mapping list. So the first thing we need to do is find those slot names. And to do that, we can look in our new character and use property list.find, and then it's slot name plus link. So that's going to return us the mapping slot. And then for the joint object, we can use find model by label name and pass it the joint name from our dictionary. So we can say if it finds a joint object, then we can append that to the mapping slot. So if we test that now, we can see it's gone through and filled in all the joints that it's found into all the slots. So now the last thing we need to do is activate the characterization. So then we can use new character.setCharacterize on and set that to true, so that'll set it to biped, false as quadruped. Now if we run that, you can see our character mapping's complete and our characterization's turned on. So when you run the set characterization on, if there is an error, you can get it to print that error with the new character.getCharacterize error. And then if not, we can use FB application current character and set that to the new character. So our current character will be our new character. So now we can delete out our IK effectors. Now we have our character characterized and ready to use. So the final thing to do is just serialize this so we can use it on the rest of the characters. So we can reset our scene. So now we can run our script again. So the first thing we're going to do is T-Pose our character. And the reason we're getting these weird rotations is because when we zero the skeletons here, MotionBuilder doesn't know that the joints have been reset to 0. So before we T-pose our limbs, we need to get MotionBuilder to evaluate the scene. So we're going to call fbSystem.scene.evaluate. So this time when we run our T-pose, we can see our arms come in the correct pose. And then we can characterize our character, and then we have our character filled in and characterized. And then we can go in and delete these IK effectors. If you wanted to delete these in an easier way, what we can do is add the IK controls into a namespace and then delete them from that namespace. We can create an IK helper namespace, and then we can just add that into our IK helper names. And then this time when we run it, it creates IK helpers, and they've all got this IK helper namespace. And then we can create a little function to delete those. So now when we run this, it deletes all our IK helpers. So now if we want to characterize this character, all we have to do is T-pose it. Then we can come in here and just adjust these into the right positions. So you can move these arms around, straighten these legs up a little bit. And then when we're happy with that, we can delete our IK helpers. And then create our character. Now we have our character characterized, all the slots filled in quickly and easily. Hopefully, even if you don't use all the code in this video, you'll find something in there that will be useful. And let me know in the comments below if you want to see more MotionBuilder scripting tutorials. Then in the next video, we could take our mocap that we've got from our MVN system, combine it with our characters that we've set up with our script, and start creating some shots.